I gotta hide this, and we're gonna go back to that. Okay. All right, so I'll leave this up here for you to look at. Your numbers coming up, so be ready. And if you don't know how to factor, I'm going to talk you through it, and you'll have to go through that process. Right on the video, you just see me getting ready for this. I froze their screen. They just see the questions. Wrong? Dang it. Oh, that is right. No, that's not right. Oh, my goodness. Sorry, people on YouTube. Nobody's watching anyway. Doesn't matter. Fumble. Nice. Matt, did you go first yesterday? No, Matt. You went first yesterday, didn't you? But that was that other calculator by hand. So it's weird. This calculator on here picked you first too. Sometimes I feel like there's an algorithm about, but I don't think so. I think it changes every once in a while. So there you are, 1 through 22. Okay, so let's get this ball rolling here. How do you factor that first one? What did you get in factored form, by the way? Yeah, we screwed up last hour, and I wrote it. A student said minus 15 plus 2. That sums to negative 13, but then that multiplies to negative 30. So, and I actually wrote it, and I wasn't even thinking. I didn't do the good FOIL or good factor. And I'm bringing that up as a point that I was wrong to not check the answer. I just was thinking about other things. The student, that was okay that they were wrong, but you got to check that FOIL. That's the good FOIL or good factor concept. But then, Matt, what does x equal? Students often screw this up. Go ahead. Sometimes they just say 10, negative 10, and negative 3 and think that's the answer for what the solutions are. No, you factor through the MA numbers, MA, and we do that because this is just 1x squared, so it's a simple MA process. But then you set each one of these equal to 0 and solve. And some teachers are better than it at others about being sticklers. Hey, write the zero product property. And I guess I should make you do that so you don't make the mistake of saying negative 10 and negative 3 are the final answers. So I do want to make a point to that. But I thought we were at a level that we could make that, write it in factor form and then just write the zeros. So, there's give and take. Try to treat, where we can make this as easy as possible. But then I think that's nobody. Sorry, in the middle of a video here too. Ed. Lizinski? Is it Ed? Evan. It says Ed. I didn't know I had an Ed in here. Yeah, weird. We don't have a 6. Do we have a 13? 4, 8, 12, 13? No! Hey, Scott, how you doing? Hey, you guys remember Scott? 6, stop doing this. These are people no longer here. 4, 8, 12. Sorry, Julia. You're up now. Hey, Julia, did you get this factored? Yeah. What'd you get? Oh no, let's stop there. Does 4 go into 25? Yes or no? No, so it can't be a greatest common factor. So that's why I'm going to stop you there. What it is, though, is a difference of 2 squares. And that's what we need to recognize right away. What's the perfect square of 4x squared? What times what equals 4x squared? So that's 2x and 2x. Good FOILers, good factors. That's why this works. And then what's the perfect square of 25? Put that water away. You're not taking notes. You don't get to drink water by class. Ciao. You can take a drink, but that drives me nuts. Next thing you're going to be doing is sleeping on me. All right, what's the perfect square of 25? And I don't care if that's in the video. Blah, 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 blah. This is teaching in a high school. He's crinkling that bottle. Stop crinkling that bottle. Put it away. All right, and then what do I put in between those two? Plus and minus. Okay, good. Sorry for screaming. Maybe I scared you. I meant to. I don't like this. What's going on? All right, and then what's x equal? Don't like it at all. So what's x equal? Okay, fine. I should put this equal to 0. So let me erase this as my heart's pumping. Ooh, feel alive right now. As Ivo yawns and takes half the oxygen on this side of the room. What's x equal? 3/4, he says. So Julia, what's x equal? So subtract 5, divide by 2, what do we get? Negative, because we subtracted. And then what's x equal over here? Maybe you were telling me that one, right? Just say that. Good. All right. And then those are the two zeros. All right, next one. Boom, we're doing it because I just like this. 4812. Is that Evan? I mean, I'm sorry if I'm going to call you Ed now. All right. Hey, did you just unfoil this? I hope. Good. What'd you get? Now just prove. Awesome. And that's a good shake of the head. I was shaking my head like that's just. Sometimes he was awesome, just great. All right, and I hope he didn't do 4 steps. Right. Okay, so it is a guess and check. The reason is this has to be 5x and 1x. And that's what I've been trying to pound in your brain here about factoring. We really got to wean ourselves away from 4 steps. I hardly ever do it, but sometimes I do. And then this has to equal -6 when I multiply those two. And then we check the middle term. And Evan is correct. 10x plus -3x is 7x. So I'm good to go. By the way, Evan, what are the answers for x then? There we go. And now that's a fast one. And you know how to factor. It probably means you know how to FOIL from what I heard from me a million times. Okay. Now I canceled all these things and I did want to do another one of these. So actually, that was considered bell work. This is just considered I'm terrified of students getting this correct on the test. So I want to do another one. All right. I just dealt with somebody in tutoring, which I'm glad they come into tutoring, but then they also come in saying, I don't even know where to start. And that is unacceptable. And I'm just going to be honest with that person and anyone else that says you don't know where to start. That means you're not using your notes. You're not engaged in the notes. You're not getting at least some components of the notes. And this has got to get better, especially for those that are saying that they're struggling here. It's got to get better where we know how to use our notes. The reason why we take notes. All right. And then we can refer to it. And then in the fact of you writing the notes, it actually your brain is activated during that time. And then you can say, oh yeah, I remember doing that. Now I know what to do. I think that's a lost component with this technology these days and wanting to get answers quick and there are some problems going on here that need to be addressed. So I'm going to put you on the spots. All right. Poor Julia just went, or no, was that Julia? Is that you, Julia, that just went last 15? No? Oh, that was Ed. Oh, 16. Gabby. Nice. And you get your names, first names mentioned on you're famous. All right. So what goes up on the top blank first? I'm not doing anything. Oh, look. Oh, you're right. I'm sorry. I just scared you. I was thinking about something else. My bad, dog. You're right. 3x squared. And I'll take the rest. You getting that is, half the thing here, but not really. There's a lot more. And I'm only going to do this once because then these lines get in the way. But anything I put up in that blank has to be distributed. And then you organize your terms right here. See, again, I'm gonna say this, and it's gonna make you mad, and I don't care. This should not be that hard. You just keep yourself organized, and you follow what's going on here in the long division process. I should say plus a negative 9x squared, and then 3x squared times 5 is 15. Jumping the gun there, 15x squared. But I am gonna ask you this, Gabby. What do I do with this whole thing? Subtract it. So maybe for the purposes of this video, I'll make this beautiful with colors. My shoulder is like out of whack today. And then distribute that minus sign. So seeing that maybe in green, that'll stick out more. All right, it must be distributed, that minus sign. Lexi Samulus subtracts at this point. We should. Okay, and then that's the biggest missed thing, the not subtracting. Minus 15x squared plus 4x. And then let's get another student. This is important. That's why I don't care how much time this takes. 4A12, 4A12. I was wrong. Ashka, you got away with one. 4A12. No, maybe not. Did we have 13 before? Oh, Ashka's not even here. That's Scott. Did we have 13 before or not? Yeah, okay, so Scott was twice. Hi, Scott, wherever you are in the world. What was that, 5? Jake. What goes up in the blank? Jake, you awake? Okay, what goes up in the blank? Okay, that's why we should be taking notes and not drinking water. Focus on that. Focus on this. What times x squared equals 4x cubed? We'll wait. 4x. That's what goes up on the blank. I'll leave you alone until I ask you the next thing. You distribute this. I don't want to do the lines because then the lines get all crazy, right? But we should know that we distribute this. Minus 12x squared. 4x times 5 is 20x. What do I do with this, Jake? What goes on the outside? The opposite operation of this, Jake, I'm going to make you say it. So what goes out here and what's the opposite operation of that? Minus. And then what do we do with that? It starts with a D. Tell me. What do I do with that minus sign? Word that starts with a D. Distribute. And I do want to distribute with a green to show that what these were originally, and then the green is the new introduction of the subtraction of this. Delete. Then this becomes negative 3x squared minus 16x minus 6. Oh my gosh. Computer was going crazy there. All right, getting another student. Boom. 3. Nice. Kathleen. Okay, what goes up on the top blank now? Boom. Awesome. So negative 3, and I'll leave you be the rest of the way here. Because we should know that we do this. Negative 3 times negative 3x is 9x. Negative 15. But before you do anything, you subtract. And those that get this fast, do that right away, right? Don't you do that immediately? Once you write these down, then you make all the signs opposite. That's when you get the ball rolling and really get to understanding this. Then this is negative 25x. And this is plus 9. Okay, this is what I told you yesterday. This is what you want to do, but I didn't really give myself enough room, so it's going to be ugly. But don't rewrite the answer. Go back up here and put plus. Come on, pen. Plus, and then, I'm sorry, this is really bad. I didn't give myself enough room. Tack that on as a last term. And then, by the way, why is this a remainder? Because the numerators or the remainder, the degree is smaller than the divisor. There's nothing else I could divide. I can't think about what I would put up on the top blank. I mean, once I have a constant as that last term, it's over. Yesterday we had something special happen, which was unique. And then all of this messily is the answer. I wish I had all this stuff out of the way that's doesn't need to be there. Oh, fine. That's supposed to be in this blank. All right. And you can do that on the test too. I wouldn't care. All right. And then I do want to do one more of remembering how to do this by synthetic division. So I want to test if we're where we need to be on that. 12, 4, 8, 12. Is that you again, Julia? Oh, poor Julia. Hey, Julia, if I'm going to do this through synthetic division, what goes in the blank there? Boom, shakalaka. And I'll take care of the rest here as far as setup. This is in nice descending order. Hopefully there were questions where they weren't in descending order. I should have those, I think I had one yesterday where we had to switch the x to the fourth and the x to the third. But don't just blindly put numbers there. Make sure this is the x to the fourth, x to the third, squared, x constant. Okay, Julia, I guess I'm going to bother you two more times. What goes down here? What number goes there? And then what number goes here? And then what number goes here? I just wanted to make sure you weren't doing anything crazy like subtracting. No, you just add. It's different than regular division. Okay, you're good. 3 times 1 is 3, and then this is 10, 30, 27. Ooh, I just remember this from last hour. Okay, and one more person to bother before we get into the new stuff. Ooh, 18. Where the heck are we at in the room? Is that you? Yeah. Nathan, I almost said Quinn, because Quinn can be a first name. Hey, everyone watch, what's the name of the show with Quinn in it? The 4 guys that do, stuff, they challenge each other. No one knows that show? Quinn's in it as one of the guys. Do you know it? Impractical Jokers. We love that show. So Scott, what is the final answer then? Remember, I didn't tell you. This is divide. So I'm dividing polynomials. So what's the final answer? 2. All right. So, my pen just did something crazy there. Good. Keep going. Oh, sorry. You said cubed. My brain. And then what do we do with that 82? Oh, it's 82 over x minus 3. Remember, it's a remainder over divisor, just like in grade school. Try to think of grade school when Lexi had that remainder. She had to take that remainder divided by what she divided by. And it's a mixed number after that. And don't forget about the plus. I was doing the pluses for you. People often miss that. You're gone. I got to take a half point off for math syntax. Not because I enjoy it. I just feel I owe it to you to make sure that you don't make that mistake in the future. All right, now let's go to completely something different. Have your calculators ready. Go ahead and snap it out of your bag. That's your calculator? That's not a grapher, is it? Oh, do you know when that said, oh no? Okay, gotcha. Cover your nose, by the way. All right. Students can't cover their noses anymore. I'm going to get tape and just tape it to their nose bridge. Okay, I'm just saying. I was just looking in the general areas. Alrighty then. Okay, so this first one, you don't need a graphing calculator because here it is. And then this leads to what we need to do in this stuff. You got to look at a picture to help you to do this. But then this is what your work needs to look like. Okay, so reading the directions. Oh, I didn't follow these directions. Basically, I just found the zeros. And we'll go from there. And I should have noted that they're rational or irrational. Okay, look at this graph. What does it look like this is as an x-intercept? 3, 2, 1, go. -3, it's simple. What does it look like this one is? 3, 2, 1, go. 1. And then this one looks like it's a fraction. So, oh no, I can't tell you exactly what that one is. And this is going to happen more often than not in the future. That's why you have to do what I'm doing today. Wax on, say it. Wax off. Who was a Karate Kid person? Anyone see that original movie? Couple? Wax on, wax off. Trust your teacher while we're doing this process, because it's actually going to be a process we're going to use for like the next 2 weeks. All right? And that's why we've got to get it down early. All right? So here's what you have to do. Okay, this one you're given the picture. And it looks like -3 is an x-intercept, which means -3, sorry, I stopped writing that, should be a 0. I should have started with that same thing I've shown you over and over again. A 0 is called a root, which turns into an x-intercept, which turns into a factor. Remember those synonyms that I told you about before? For that to be 0, everyone tell me what should happen here at the end then. What should this be right there? 3, 2, 1, go. 0. And here's why. It's the remainders theorem. Input, say it. That was the last part of your homework yesterday. Synthetic substitution, where this is the input, the remainder is the output. If this is truly an x-intercept or a 0, 0 should be the output. Now we're getting some connections between what we've done, in previous assignments. So let's prove it. And that's why we waxed on, waxed off. We did a synthetic division as a little review before going into these notes. Really try to make things as simple as possible, no matter what anyone wants to say about me. You could say a whole bunch of stuff. I don't really care. That's not right. That's 66. Really try to approach things to make it as the most direct, simple way to get things done here. All right? And now that's proof. Yes. So when they say, what are the zeros? The graphing calculator already showed me -3, but your homework, you need to prove it. Because then here's the next thing. Now this is a depressed polynomial. This is 5x squared minus 22x plus 17. And now what I want to do is solve for this by factoring, which you'll be able to. Let me get a student, though, and I'm going to help you on this. I'm going to tell you what that other 0 helps you do. Student number 6. That's another no. It seems like this calculator knows who's not here. 13. Is that a no? Is that Scott? Hi, Scott. 21. Nice. All right, here we go. So, Carolina, correct? This was a 0, which is 1. What does that mean that the corresponding factor would be from that 0? Because now I'm going to use that 0 to help me factor. Boom shakalaka. And now I can help myself by factoring by being a good foiler. So what times x equals 5x squared? What has to go there? 5x. Now we're getting the foiling factoring thing. We can use the graphing calculator to help me. And then what times negative 1 is positive 17. So that's what this term would be. What's the answer to that? And now you've got the other factor through reverse analysis of the other 0. You see how that works? You can use that or just factor. All right, and that would be the factorization of that 5x squared minus 22x plus 17. Okay, sorry this got in the way of where I'm listing my zeros. Yeehaw! I'll move this over. And then Carolina, I am going to bother you one more time. You did say 1 is a 0. What's this as a 0? When I set this equal to 0, what do I get for x? Boom shakalaka. 17 over 5 is, oh, okay, now look at that 0. 1, 2, 3, and 2/5. All right, it's in between 3 and 4. That makes sense. And that's what we need to do. So this has to be all of your work and your homework. Any bums that show me no work and just show answers, you're getting a 0. I'm done. I'm done with the lack of quality of homework and how that's translating to 30% on my tests. All right, it really is in some cases, and it's not the good. Okay, so do I see a picture for this? Yes or no? Make your own picture, all right? And I'm not yelling at you, but that's the point of having the graphing calculator now. Turn this exactly into the question we just did. I'll do this so I'm out of the way, and I'll use the screen in class to see the picture. Clear. Gotta clear a couple things. You're definitely going to be ahead of me here as I take forever to write this in my calculator. 3x, and you want to just practice that you can type it on your own, and I don't know where you're at with the graphing calculator, how often you've used it. So, you just want to play along. That's all I got to say about that. Good thing when I go to the calculator, I'm very slow in typing because of using my keyboard. It's kind of a pain. All right, and then unfreeze. Okay, so hopefully you're at where I'm at. You go into Y1 screen. You hit graph. I'm not pulling my graph onto my notes because it doesn't work. This note system stinks. I hate my program I have to use. But anyway, that's me complaining. What does it look like, everybody? What number? 3, 2, 1, go. -2. I don't know. What does that one look like? 3, 2, 1, go. 1. So I might use that one for help. I'm going to go with my first one, though. I'm going to prove that -2 is a 0. All right, so I don't really have anyone to bother on this. I mean, I hope at this point you know how to synthetically divide and know what I'm setting up here. -6. It always makes me sad after all the numerous examples of synthetic division, I still have people not being able to even synthetically divide. I don't know what you want me to do with that, man. Boom, proof, all right? And that's what's supposed to happen. If you do not get 0 at the end, you did something wrong. It's either your math's wrong in the middle, you synthetically divided wrong, or you typed the equation wrong and something happened, all right? But now we have this depressed polynomial. Oh, I guess I'm going to bother someone now. Let's cheat and use the graphing calculator again for those that have really big troubles with factoring. Let's second quit. Let's get that student. Is 17 somebody? 4, 12, 16, 17. Ashka, she missed today. Ashka, I hope you watch this video, you get mentioned. All right, Mitchell. You probably don't need this, but What was the other 0 that we saw here? So it's, oh, sorry, careful. It's 1 as a 0. What does that mean one of the factors have to be? X minus 1. Okay, so that even helps me with my factoring. What does the other factor have to be then? Absolutely. Or just factor. If you don't want, if you're a good factor, this is not a tough one. All right. So what does that mean the other two zeros are? So one is -2. What are the other two? 1 and -1/3. Good. Okay, subtract 1, divide by 3. So of course, we can use our calculator to find those zeros. That's not the point. Wax on, say it. You are going to have to do this because the calculator is not going to help you eventually. The calculator will not be an aid that perfectly gets all the zeros. You got to have this process of being able to depress the polynomial down to an x squared and then find the zeros through factoring or something different. Interesting, I said that. Okay, so let's do this next one. I'll freeze the screen. Something special happens with this one. All right, and then this goes back to something I've told you again. I've actually eliminated a lot of stuff throughout the last couple chapters that other students back in even last year had to do, because I'm trying to wait when it really comes into fruition here and really focus on the other things and make sure you're really good with that. And I don't know if that's happening with some of us. Many of us, we're good. We're rolling. We're getting the ball rolling here. And some of us, it's just not. But now is the time for a thing that I've not brought up yet, actually, that's going to happen in this question. And then if we're the student that says, oh, that's like beyond my capability, again, this is something that you're supposed to know from the past. So here we go. And I have something on your calendar to help you remember. You don't even know what I'm talking about yet. But look at this. Oh, no. Oh, no. Oh, yeah. What number is that, everybody? 3, 2, 1, go. Looks like 4, right? Be careful on the counting. And if you miscounted and put 5, you just wouldn't get 0 at the end. Recheck. Oh, 1, 2, 3, that's actually 4. So the other two zeros are decimals. So we'll figure out what those are after I depress this polynomial. So the only thing with these is you use your calculator to find those other zeros. Boom shakalaka. Proof. Okay? And that's what has to happen. And don't tell me I'm going too fast. We should know how to bring down the 1 and then multiply, add, multiply, add, multiply, add. Okay? All right, let's get somebody again. Let's go through this discussion with a friend. Another forced friendship from Mr. Samuels. Is that him again? Holy cow. Scott. 14, 15, 16. Gabby, you're up again. Calculator loves you. All right, so it's a depressed polynomial. I hope you get that. X cubed is now an x squared. Gabby, does this factor? That's what last hour said. I'm just saying, just a random comment. Are we sure? I know what last hour thought too. If it was this, I think you'd be good. But it's not. So if it's not factorable, oh my gosh. Does anyone remember this? How to solve a quadratic when it's not factorable. Yes. Quadratic formula. Here we go, everybody. And then this inspired so much anger last hour. I think students wanted to literally kill me, but I don't care. If you have problems remembering this, watch this like 34 times tonight. Anyone want to dance? Evan, are you paying attention? Jake, how you doing?
X is equal to negative b plus or minus the square root of b squared minus 4ac.
Hi, you're not even looking. Are you ignoring this?
X is equal to negative b
It's gonna be
plus
stuck in your
or
head,
minus
Matt.
the square root of b squared minus 4ac all over 2a.
One more time.
X
The
is
big
equal
one.
to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yay! All right, so those that really enjoyed that, nobody. It's right here on the calendar for you to watch at your leisure. Because I'm going to tell you this right now. There are no excuses for not having it memorized. So you have to have it memorized. There is no I don't get it on the quadratic formula. You either lock it down or you don't. All right, and that's what we're going with on this one here. So, yes, you've done that before. Yes, you were actually tested on it in I think maybe not. I think in chapter PR we kept it off the test because we're like, you know what? Let's just try to get the factoring down. And then I know on the chapter 1 test we didn't have the quadratic formula come up again because we are trying to, limit how many things we're asking you at this point. Now is the time. We can't limit it anymore. You need to know the quadratic formula. So we got to stop this and got to get this going. So the opposite of b plus or minus the square root of, stop! I swear to gosh, this drives me nuts. What's a negative squared, by the way? What's a negative times a negative? A positive! Do you know how many students put a negative in this position? It drives me crazy because they use their calculator and they type -2 squared without putting the -2 in parentheses. Never put a negative in that position. That is on you if you do that. All right? Please, please don't do those simple math errors. All right? Those have got to stop as a senior in this high level math class. All right, so I put -2 squared is 4, hammering down that this is always a positive in that position. All right, a negative squared is a positive. These simple math skills that are really crushing students. What's a negative times a negative, everybody? Positive. So this is 4. 4 plus 4 is 8. Okay, and then I'm not going to get a big, long, major discussion about how do I simplify the square root of 8. 8 is 4 times 2. What's the square root of 4, everybody? 2. So everyone should know real quick that this is 2 root 2. That's what 8 is. Oh, I think I'm getting a low battery. I am. I just saw my screen go low. I might have to do the next question at my desk. All right. Now, do not do this. That's illegal, canceling those 2's like that. So I did tell my other hour, if you are afraid, how do I simplify this next? Then go ahead and split this up into 2 fractions. This is perfectly legal. And then you reduce each parts. Oh, okay. 2 over 2 is 1 root 2. And then my fractions go away completely. I get students do this all the time. I call that a 6 over 5 equals 2 error. I think that's something I've referenced in class before, and I'm not doing it right now. You just can't do that. You can't cancel part of a sum or difference with something else like that. So those that get real good with this, they know 2 goes into all of these and come right to this anyway. So one way or the other, we got to get that final answer. By the way, root 2 is 1.414. I think I said a wrong thing last hour. And then when we look at this graph, 1 plus 1.41 is 2.414. 1 minus 1.41 is negative 0.414. So you can't have decimal zeros. You have to understand that. Those are actually still x-intercepts. They're just ones I don't know the exact for. And that's really where this is getting to, exact answers, knowing how to get those. So what were the zeros for this question? These 2 and the original, which got the ball rolling, 4. So don't forget about 4 and 1 plus or minus the square root of 2. And then the direction said this is rational. That's a rat. And this is an irrat. This is an irrational zero. I'll tell you the big difference with section 2.5. They throw in imaginary zeros. That's really the only difference between 2.4 and 2.5, with a couple other different questions that I've waited for. I really want to make sure we know how to synthetically divide. Okay, do the same thing on the last one. I got to go to my desk to plug this in before it shuts down. To be that teacher that sits at the desk here kind of thing, trying to get the screen. How come that won't show up nicely? There we go. My big fat head's in the way. Okay. All right. So 2x to the fourth, just to emulate. We do have a problem with this one. So this is, you better super pay attention. I can't hold our attention for as long as I go here. That's a problem. Wait till college. You'll have hour and a half classes in college. If you do night school, those are like 3.5 hour classes. Oh yeah. True that. There'll be a break here and there, but man, you'll be doing stuff that whole time. We're expected to. Oh, I hit those. What happened? There we go. 1, 4. Is that x squared? Anyone ahead of me? Did I change this one? This is supposed to be x squared here. So I did screw up there. This is x squared. Sorry. This one is not. My bad, dogs. Delete. Hopefully that deletes completely. No, it doesn't. That's stupid. This is squared. I know it doesn't say squared up there, but it's supposed to. It wouldn't have 2 consecutive cubes. So a typo that I did not catch from back in the day. How come that won't delete? There we go. 14x. This is thrilling. Hey, let's watch that guy on YouTube that can't type on a calculator. Oh, okay. So let me just reiterate. This was supposed to say squared. This is a typo. I wouldn't have cubes right next to each other. Okay. All right. But there's a bigger problem with this one. And it's something I didn't expect to have happen. So I made a little mistake on this example. Wow, this is taking a long time. There we go. Oh no, decimal, decimal, decimal. Oh, 3 decimals and then a nice, what's that 0 right there, everybody? What is it? 4. But then a decimal, and a decimal. And I'm going to tell you what the big problem with this is. I definitely wanted this. I wanted an x to the fourth because I wanted a question that you have to double depress. You have to depress it twice. You have to get it down from an x to the fourth to an x cubed, and then knock that x cubed down to an x squared so that you can find the remaining 2 zeros. But I was hoping that these were both integral zeros. So it's actually this one that I want, and it is, and it looks like it's at like negative a half. I know that looks like it's at 1.5, but it's not. So what did I have to show my other class? I had to prove it. And I didn't want to show this feature yet, but it's coming up anyway. So go to y2 and make y2 equals 0, and we're going to be fine. We have time, and I don't care. So y2 equals 0, there's a reason. What that is now the x-axis. Look at my glorious calculator. It actually has colors and shows that. How many people have colors on your calculator? So you get to see that. Sorry, you get to see that red line come through and see that it exists. Now, second, calculate. I'm not going to find a 0. I have 2 graphs. I'm going to find the what? Intersection. This is a way better feature than finding zeros. I'm just telling you. There it is. Now watch what I see when I get this one, which you have to hit enter 3 times. Guess that stupid thing like when we had maximums and minimums. Oh no. But fortunately, I know what that means. I know what that actually is. But it's not a nice perfect number that I can use through synthetic division. So we are eventually going to have to do this. Son of a nutcracker. That's the slow speed of my calculator here. It went past. I should just hit 5. I hit the arrow and then it moves like a minute later. Very slow memory. Let's see what this one is. First curve, second curve, guess. Negative a half. Okay, so on the calculator, I see nice rational zeros of 4 and negative a half. So those are 2 of my zeros, but I have to prove it. And this is what your homework must show. You must show that you can prove that's a 0, but also depress this polynomial twice. Bring down the 2. 4 times 2 is 8. And I hope you really get that. I hope you get that what I'm writing here is a depressed polynomial once. Perfect. What I'm seeing is true. Now I have an x cubed, and I want to depress it again with the second 0. This column no longer exists for my second depression, all right, because this is now the constant. Bring down the 2. Half of 2 is 1. 1 plus 1. Wait a minute. This is different than. Oh, it's negative a half. Oh, thank goodness. Woo! I knew something was going on wrong there. Half of negative of 2 negative is negative 1. And then I am getting infinitely sad people that can't handle fractions. Like just simply what's half of 4? What's half of 4, everybody? 2. And negative times a negative is a positive. So that is 2. Proof that half was the other 0. Jake! All right, so now 2x squared. This has been depressed to an x squared, an x, and a constant. And now I have this to left over. Do you think I used the quadratic formula for this, yes or no? This is a chapter P question. We did solve quadratics through various ways. All right? So one of the ways was just by solving using square roots. Problem is sleeping in my class. Never like it. Never let it happen. It just leads to problems later. And sometimes those are the students that complain about their grade. Hopefully that's not this person. Really drives me nuts. Plus minus. And that's where the third and the fourth zeros come from. If you wanted to clean it up and put them all together, that's fine. But that's what actually happens. You square root both sides. It's a plus minus answer, though, just because. All right. And I've covered that before, that whenever you square root both sides of an equation to solve an x squared, you put a plus minus on that. So if you ultimately look at what we did new, it's only these. And that's what I'm expecting you to do. Oh, I'm sorry. One more thing. Your homework actually says determine if, I'll just make up one, is, I could just make this up, x plus 1, a factor. This is how your homework starts. Of, and then I'll just make, I don't really care, x to the fourth minus, this would be a miracle if this actually works, plus 2x squared minus x plus 1. Remember what I told you about factor? Factors are these binomials, which means if that's the binomial, then a 0 would have to be negative 1, right? Right? So if this is truly a factor, this would have to be a 0. So to answer this question, I test it out. And then what should I have at the end if this is true? What should be right there, everyone? Say the number. 3, 2, 1, go. 0. What if it's not 0? What do you say? It's not a factor. So that's how your homework actually starts, just to make sure you know how to do everything. And if this is a factor, I'm going to fall off of my chair. No, it's not, because I just made these. I just pulled this out of my brain. So I could stop at this point and say no, because I know this is not going to produce a 0 at the end. Not a factor, because this is not a 0. So that's how easy the homework starts. But then I'm afraid if I didn't cover that, then we wouldn't understand that. Okay, so that's the end of the video there. The homework should be probably 1/3 as long as these notes.